Hi guys, welcome to 314 part 2. So we're going to look at domain restrictions, how to graph a full cycle, how to also graph it in your calculator as well. So on the very first page of 14b, I want you to take a second, maybe pause it. Actually, well, I'm going to leave that up there while I kind of talk through it. So there's some domain restrictions to graph a full cycle of the curve. Actually, I lied. I'm taking it away for just a second because I want to show you on this thing, okay? So if we're talking about a full cycle of the curve, what I mean is at a certain point, it's just going to retrace over itself. So if I take cosine of x right here, and I start at 0, we're making our circle, we're making our circle, we're making our circle, we're making our circle. Okay, now we're back to where we started. Now we're just tracing over, tracing over, tracing over. So when I got to pi, I had completed a full circle. I had completed the whole graph. I wasn't getting any new information once I got past that point. All right, so what if I had cosine of, let's start with 3x. Okay, same idea. I start at 0, I'm making my graph, I'm making my curve. That looks good. And right here, I've now completed a full rotation at pi. Once I get there, I'm just tracing over. Well, we said that what about if n is even? That should be 4x. It's x times 4, but I don't like how that looks. Okay, so there's going to be 8 petals, right? There's 2 n petals. And then I'm going to start. So I'm tracing my curve, I'm tracing my curve, I'm tracing my curve, I'm at pi, but I haven't traced my full curve yet. I'm still getting new information, I'm still graphing new pieces until I get to 2 pi. Okay, so this one is 2 pi. So rose curve, remember we said if it has n petals, remember rose curve is in the form a cosine of n theta or a sine of n theta. If n is odd, then it will have n petals, meaning like if it's 3 theta, it'll have 3 petals. And I'll see a full cycle on 0 to pi. This stuff is not super intuitive, or there's not a great way to think about it besides memorizing. I'm hoping that on the AP exam that they will give you these with a calculator because it's pretty easy to determine with the calculator. But this is just in case if not. So that is for a rose curve. If it is a circle, like 4 sine of theta, 4 cosine of theta, those are always 0 to pi. And if it is a limacon or a cardioid or one of those, it's always 0 to 2 pi in the form a plus b cosine theta or a plus b sine of theta. So let's look at something like this. Oh, I said I was going to try and remember to erase these, but I didn't. Don't look. Don't look at the answers. Okay. Go ahead, while I'm erasing this, go get your calculator in front of you if you don't already have it in front of you. Okay. All right, so first thing I'm going to do is identify the type of curve. So in this, it's in the form a plus b cosine theta. So this is a limacon. In this case, it's a cardioid. Okay, and we said those are always on the interval 0 to 2 pi. So that's not too bad. This one is a rose curve. N equals 5, which means it's odd. So that means my interval is from 0 to pi. Let's go ahead and look at this on our calculator. So if you go to your calculator and hit mode, mine is already there, but make sure first that you're in radian mode, and then make sure that under function, yours is probably on function right now. Scroll over, hit polar, and hit enter. Then hit y equals, and you should notice that now it says r equals. And if you type, you get theta. So I'm going to go ahead and graph this. Okay, if yours looks a little flattened, I went ahead and did c square, which is 5, which takes it to like a square window. All right, so if you go to my window right here, we said that this was 3 plus 3. That should be in the interval 0 to 2 pi. It's done that for you. Let's say if I change this to pi and I graphed, notice you would not see the whole curve. Okay. So you can always kind of check if you have your calculator. Let's do what's the one we just did, 4 sine of 5 theta. And I'm on the window 0 to pi. That one does graph the whole curve, and that's really pretty too. Okay, so you can check by using your calculator in polar mode. This one is a rose, but n is even. So I would need 2 n petals and 0 to 2 pi. And this one is a circle, so therefore it's always 0 to pi. Okay. All right, so let's go ahead and then look at example number 7. No more answers. So it says use the rectangular graph. Rectangular just means my normal x and y. So make sure, remember when we converted to rectangular coordinates, that's what was at x and y. 2 cosine of x minus 1. And we want to find where the y values are negative. So let's go to my GeoGebra. All right, it looks something like this. Okay, another way to write that would be -1 plus 2 cosine theta. If we think about it in the term of a plus b. So where it's negative, well, it starts being negative here and then all the way to somewhere over here. Let's do this algebraically. When it's negative is when it's less than 0. So when I solve this, I get cosine of x is less than 1/2. Well, where does it equal 1/2? At pi over 3 and at 5 pi over 3. Everywhere between those values, it's less than that. Okay, so that would be my answer for this. Think about in quadrants 2 and 3, it's definitely less than 1/2 because it's negative there. Domain of one complete cycle, this is a limacon, so 0 to 2 pi. Symmetry, because it's cosine, that is the x-axis symmetry, or sometimes you'll hear it referred to as the polar axis. And then if I wanted to graph this, it would go out to a maximum value of 3 because 2 plus 1. It would be on the x-axis because cosine is positive, and it would be with an inner loop. Oops, I'm very bad at drawing that. But you can see it on the GeoGebra. That's what it looks like. Goes into 1. All right, and then the last thing we're going to do is intersection of polar graphs. So we want to find the points of intersection where r equals 1 minus 2 cosine theta and r equals 1 intersect. The easiest way to do this algebraically is just to set them equal to each other. Subtract 1 from both sides. And I'm looking for where does cosine of theta equal 0. That's going to happen in 2 places, where theta equals pi over 2 and 3 pi over 2. We want to write these as ordered pairs. In polar form, remember that's r comma theta. So r is 1, because it tells me that right here in both of these. And so those would be your solutions. So nothing we haven't done before in rectangular form. It's just kind of converting those same ideas into polar form as well. Okay. So that wraps up 314. Hopefully that's kind of you're working through that at least and making sense in your brain as well. Have a great rest of your day.